So this is, you're looking at it. So these are something that is very boring. Yeah, boring, right? So this is comparing numbers, make it from small to large. You can ask your little brother to do this for you, right? Yeah, it only takes time, but this is very boring. But there is something that is exciting. I guess every one of us has tried sometime to use Google Map, right? The Google Map is very convenient. It helps you to find where the place is, and also you can have a look from the satellite view and how it looks like around. And it also helps us to find out, so if you are at the school and then I want to go to the, let's say the Taipei Zoo, okay. Yeah, I don't know why we want to go there, but yeah, let's say you want to go to the Taipei Zoo. What is the best way to go? Okay. Now, best way, there are different kinds of definition. Maybe they will ask you, what is the transportation means that you are going to use? Are you driving? Okay, maybe if you are driving, then are you a good driver or experienced driver? Maybe, yeah, like me, I'm not that experienced, so I will try to avoid turning left. Turning left is difficult, very difficult. Yes, very. Or getting into a road that is very narrow. Okay, highway is sometimes maybe not too bad. Okay, because highway has fewer cars usually. So they will ask you some options that you want to take, and then define or to design the shortest way, the shortest path between your starting position and the place that you want to go. Okay? So this is a very well-known problem in computer science. It is called the shortest path problem. Okay, so this is a problem that is, okay, we can use some mathematics to define what is the problem look like. So we have a map usually. So what does a map look like? A map has some points that we are interested. So maybe the road junctions or the highway entrance or the highway exits. Okay, the points that we are interested. So we are going to use so a graph looks like this. So we are going to use a concept called a graph to represent a map. So we have some point of interest. So maybe this is interesting. And then between the points of interest, there are some connections. Maybe we can connect in this way. Okay? So that means that I can go from here to here. Maybe there are arrows here as well. So I can go from here to here, but I cannot go back like this. Maybe it is a double arrow. So I can go to here, I can go to here, and something like this. So we have some kind of a map that looks like this with some vertices. So we call it a vertex. A vertex or a point to represent the place. And then there are connections. So these are connections. We usually call it edge to represent whether these 2 points can go to each other. And sometimes there may be some more information, like there is a number 2 here and number 4 here. It indicates that to go from this one to this place, it takes 2 minutes. To go from this one to this one, it takes 4 minutes, estimated time. And then in that case, the problem that we have is I have a starting location, let me call it S, and then maybe there is an ending location, let me call it T. So I want to find out what is the shortest way to get us from S to T. Okay? Okay, is there a way to solve this problem? Yes, of course. List out all the possible ways for getting from S to T and choose the smallest one. And this is a correct algorithm because you have considered all the possible ways. Okay, how many ways are there? Okay, there can't be a lot because usually we won't be doing something that is very stupid. We don't want to go into a cycle again and again from S to T. So we don't do like this, right? We don't do like this. Okay. Okay. So what can a correct algorithm be? So let's give each of these nodes a number or label. Maybe let's call it 1. Let's call it 2. Let's call it 3. Let's call it 4. Let's call it 5. Let's call it 6. Okay. And then we try all the 6 factorial ways. 6 factorial ways of maybe you have 1 and 6 fixed. Then how many? So 1 and 6 fixed. So we have 4 factorial ways. Maybe you have 2 and then 3 and then 4 and then 5 and then 2, and then 4, and then 5, and then 3. Or maybe there are more. Maybe I can just use 3 hops or 4 for whatever. So there is usually a possible way to list out all the possible ways to get from 1 to 6. But of course, you will see that some of them cannot work. For instance, during the time, I may be listing 5, 3, 6, something like this. That means that I go from 1 to 5, and then 5 to 3, and then 3 to 6. But 1 is not directly connected to 5, so we should be omitting this possibility. Is that okay? But still, if we consider all the possible ways of doing this, then we can solve the problem. But it takes time. It takes time close to n factorial if we have n vertices. Is that okay? And if a problem runs in n factorial time, how large the n can run on a computer? 13? 14? Yeah, 13, 14. So this is an algorithm that works, but it is not good. If an algorithm works like this, using n factorial time or steps, then we can solve a graph with at most 15 nodes, 15 vertices. And then Google Map cannot work, right? But on the other hand, so this is why people consider this a very important problem, because over the development of computer science for roughly 50 years or 60 years now, then people are improving the way to find the shortest path. And then it is now not like n factorial. It is something like n log n. Okay, n log n, very fast. Is that okay? Or maybe n squared. You have the edges plus n log n. But the most time, yeah, but you can still manage a graph like that. Yeah, Dijkstra, right? N log n. Okay, good. So this is a problem that is more interesting because it interacts with our real life now. And then we can still solve this kind of problem with a computer. Okay? And then there is something that is also boring now. But this is still a graph problem. Maybe boring, maybe not. I don't know. I find it interesting, but okay. So this is also about a map. Okay, we have seen world map, right? So colorful world maps, I mean. So why do we want to have colors in the map? Why? It looks beautiful, right? Okay. The major reason is that for neighboring country, we want to use different color. So we make a sharp separation between the, let's say this is a, yeah, so it can be very complex, right? So everyone knows a place called Luxembourg. Have you heard of this country? Luxembourg. Okay, one of the I don't know, it may not be one of the tiniest countries in the area in the whole world. Okay, it is located around Belgium and Holland. Okay, if you are using the color that is looking similar to Belgium or looking similar to Holland, then in that it's not Holland, it's the Netherlands. It should be. So this is from my friend. Okay, Holland is just a state inside the big Netherlands. Okay, so if you are using a color that is close to Belgium or the Netherlands, then you won't see Luxembourg. It's difficult. So in the design of map, colorful maps, the basic requirement is for two neighboring countries, we should use different colors. Is that okay? Okay. Now people ask, okay, if you are not a very advanced printing company, so you cannot print maps with many colors, what is the minimum number of colors that we need? 4 colors. Very good. So this is called the 4-color theorem. Okay, a very famous one. But then this 4-color. Okay, so this is something that is discrete. We are asking what? We are asking what is the minimum number of color. So minimum, it can be either 1 or 2 or 3 or 4. You can count it. Okay, and how do you show? Okay, so for here we need to show for all possible different kinds of maps, 4 color is enough, is sufficient. But unfortunately for this problem it is so hard. Okay, so far there is no proof that you can write it down. Okay, maybe you can write it down. But so far, the proof of four-color theorem relies on computer. It needs computer to check for all the cases, different cases, that this one you can color in 4 colors, this kind of map you can color in 4 colors, and so on and so forth. Okay. But in the course, we are going to study this problem, but we are going to use 5 colors instead. Okay. Suddenly, extending from 4 colors to 5 colors will be like you are competing in the Olympics, or you are competing in the, let's say, in the kindergarten. Okay. Suddenly, it is very, very easy. We can just use very basic arguments to understand 5 colors should be enough. Okay. 4 colors, I don't know. Okay. Difficult. Okay. But okay. So the first one is logic. Logic is the foundation of proofs. So what is a proof? A proof is something that you want to tell people, that you want to convince, you want to make people believe in you that certain thing is correct. Like what? Like using 5 colors is enough to color a map properly, so that no 2 neighboring countries are with the same color. But before we talk about proofs, we still need to understand something that is even more basic. So this is called the logic. So logic is so this is a complicated argument, a complicated sequence of sentences that shows something is correct. Logic is some simple argument, 1 or 2 lines, that shows something is correct. You can somehow think of this like this. So we're going to talk about logic, and then we're going to talk about proof. So hopefully after this course, every one of us can become logical, so that a logical person and an illogical person has a difference. When you argue, when you quarrel, you are quarreling with your friends, and then a logical person, maybe you are saying something that is logical. It makes sense all the time. But if you are quarreling with someone who is illogical, then in that case, they're exchanging things. Okay, like this. So I'll find examples for you later. Yeah. Okay. And then good. The next one is something about combinatorics. We call it combinations. How many ways of doing things? So we call this a counting problem. You count how many ways are there. So this one, some of you may have studied this already in high school, but let's do this again. And then we have a concept of some more complicated things, like we are going to define what is a set. A set is some collection of things. We call it a set. So the set of integers, it collects all the integers. 1, 2, 3, 0, minus 1. And then the set of real numbers, it collects all the real numbers. Okay. And then the set of, set. Yes. But set has some relation with counting, and to the understanding of some, I don't know. Yeah. Difficult to explain at this stage, but this is something that is very, very useful in that defining things. For instance, if you want to talk about a map, so a map, what is a map? Okay, a map is actually, you can say, you have some vertices, and then you have some edges. Okay, so a map is a collection of vertices together with a collection of edges. Okay, so if you understand set, then you can use the idea of a set to define more complicated things, even like a graph or an algorithm. Okay, so it can be like this. So we are going to talk about set, or some fancy word like function. So this is the mathematical function, and also something called a relation. But don't worry about it. Yeah, we will talk about this later. Okay. And then we are going to talk about also the graphs. So some interesting graph problem that is related to that one. And finally, if we have time, we may be talking about something that is basic number theory. Okay, so number theory is something that is about the properties of numbers. Okay, so for instance, we know 2 numbers. Let's say Let's say give me two numbers, large numbers. Give me a 3-digit number. Give me any number. Yeah.
101.
Well, okay, 101. Okay. You give me a 5-digit number maybe.
15,021.
15,021. Okay, very good. So this one. Okay, let me modify it a little bit. Let's say 1101 and then 15. So a mathematical problem asks us to find out what is the greatest common divisor of these two. So we want to find a divisor of 1101. We also want to find a divisor of 15021. Okay. Okay, I know 1 is a divisor, right? 1 can divide this and 1 can divide this. Maybe, okay, using some knowledge from my primary school, I know that this can be divisible by 3. And then this is also divisible by 3, because if we add all the numbers, 1 plus 1 plus 0 plus 1, it is 3. 1 plus 5 plus, okay, it is 9. So they're divisible by 3, okay? But then what is the largest divisor of them? You can ask your computer to write the program, and then you can solve this by checking out all the numbers that is less than 1101 and see if it divides both of them. And then you choose the largest one. So this is called the greatest common divisor problem, okay? But then we can solve this more quickly. So perhaps in your in your high school, perhaps you have heard of a problem called a method called what? Euclidean algorithm or Euclid's algorithm. So it is this is discovered by Euclid. Euclid's algorithm in Chinese. Louder. Yeah. My Chinese saying is not good. Yeah, louder. Okay, can you hear him? Okay, I try to repeat. Okay, using my Hong Kong style Chinese. It's 辗转相除法. Okay, if you have not heard of it, could you please raise your hand? Not. Okay, everyone knows. Okay, no, not heard of it. Okay, I will tell you later. Okay. Yeah, even if we don't have time. Okay, I will tell you later. But this is a way that you can do this much faster. So one method, let's call this number, the smaller number, let's call it n. Is it okay? If we try all the numbers less than 1101, then we will need n time, order n division operations. But maybe you are cleverer. Okay, maybe you will say that, okay, I don't need to check up to n. Because if there is some divisor of this one that divides this, then let's choose. There must always be one that is smaller than this. No, I should. Let me see. Yeah, it's not true. Okay, so in the worst case, n time, maybe square root n or n. Yeah, maybe the square root of this number or the n. But then, if we are using this clever method called Euclidean's algorithm, we roughly can drop, let's say n is the larger number, okay, larger, this is n, okay. So one method is to try all the numbers less than this number, so it is order n time. But we can make it faster to, let's say, the square root of n time. Okay, maybe. But using the Euclidean algorithm, we can even further make this even smaller, like log n or 2 log n time, something like this. Okay, then this is very fast. One is you are taking 15,000 operations, and then the other one is like taking 14 operations. Log of this number is just 14, 1-4. So it is very, very fast. So, but then you need to have some knowledge about this number theory. Okay, why this is correct. Okay? Okay, so far, this is what we are going to cover about this course. Okay. Now, as mentioned, if you go to my webpage, there is a link to some of the lecture notes for what I'm going to base on. And then my lecture notes are actually following closely about from the materials in this book. This is Discrete Math and its Application. Okay, this is written by Rawson, Kenneth Rawson. Okay, now this is a book that one of the recent books for this one, and this is the book that I use in my undergraduate study. Okay, so this is the 2nd edition and this is the 7th edition. But I learned my discrete math actually based on the same author. Is that okay? Okay, so this is the old one Yeah, you can't find this anymore, I guess. Yeah, maybe it's very expensive. Okay, yeah, if you still can find it. Now you can get this, but you don't need to. Okay, you can as long as you go to the library, or if you have any questions about the course materials, actually you should write me or Simon or Coco's email. Is that okay? So keep everything settled every class, then it is easy about this course. Okay? And then we are also using, so some of the problems, sometimes I find it interesting, so I copy, okay. I find it from another book. So this is another book with a different author. This is called Grimaldi. Probably Indian, I guess. I'm not sure. Okay, or maybe Italian. Yeah. Okay. So this is another book, and then so all the reference book or the textbook information you can find it from the overview of this lecture. So but then I want to mention this one. This is a very, very tiny book, a small book. Okay. Now, this is actually a very good book. It is written by Professor Liu Chonglang. So Professor Liu is a former president of our school. Okay. So we hire him from far away, from where? Illinois, University of Illinois, and then someone asked him to become our president, and he accepted, and then I think he is considered one of the most popular presidents of our school. So the students love him a lot. Yes, yeah, he has been doing discrete math as his research, but then this book is a very old one. But I don't recommend you look at it directly. Okay, so you should understand the topics first, and then if you want to find some challenging question, you can use this book. It's because this book, if you look at it, you just see words. Okay, maybe not many figures. Okay, so this is difficult to understand. Okay, but difficult. But this book, I guess, is like 40 or 50 years ago, but it has a lot of challenging questions. So the new books question, a lot of them comes from this book actually. Okay, and then this is how Professor Liu looks like. Okay, can you see this? So here, this is a book about, it says 学校没教的逻辑课. So he has written a lot of books, and then some of them are even about Chinese literature, like poems or whatever. So a very interesting person. Okay, so you can check for him and then see his book. So this is how it looks like. Okay, now the following is something that I want to scare you away from my class. So so you have scare you. It is because so we are running this class for a couple of years using this assessment method. So we are designing roughly 5 to 6 assignments for you. Okay, this is not that bad, 5 to 6 assignments. But what is the bad thing is the contribution of your assignment will be 0% in the final score. So what does that mean? Okay, it means that you can do this, you can do the assignments, or you can opt to not do any assignment at all. Okay, now we are going to count your, there are for two reasons why we are doing this. So first of all, computer science students are very smart. that when there is only one source of the assignment, then every one of them can. So this is the case in my undergrad study. So usually for a class like 100 people, there will be roughly 5 or 6 basic versions of the assignment. Okay, and this is not healthy. This is what I think. Okay, so the most thing that we want you is not about you are fulfilling the requirements set by us. We want you to learn things. So instead of wasting time doing the copying, this is what I say, then better we discourage doing the assignment by copy. And then the second reason is, of course, I want to save my tutors' effort. Okay, if they have more time to mark your exam, it's better to do so rather than mark your assignments and the exams. Okay, So we are going to carry 3 exams. So the exams will be like, so they are not contributed equally. So the best 2 of your exam grades will contribute each about 40% of the total mark, and the remaining one is 20%. Okay, so for instance, you score very lousily in the first exam. Don't worry, you can set this as your as the least score. Okay, so under this scheme, so for instance, if you get 100% in 2 exams, you can forget the third one, because you get 80% already, unless you want A plus. Okay, but 80% is okay, passing. Okay, if just let's say you just want to pass. Okay, and then yeah, because of this. Okay, so this has good thing for us. Okay, for the management, because we save our effort, but this is also having bad things to the students. Yeah, because most of the time, finding out you don't understand a thing will be too late. So you can only find out you don't actually understand what is meant by a good proof. So in the exam, we are going to ask you to write down some proofs for something, right? Maybe you are writing a proof in a very not natural way that we expect. So in that case, it will be too late. Okay, usually. So this is the bad thing. But what should we do? Okay, in this case, we will have our assignments, and then we will hold tutorial. Okay, and then we really encourage you to ask us questions. Ask me, ask Simon, ask Keke, and also form study groups with your friends. Okay, because assignment doesn't count. Okay, the assignment questions are very challenging usually. So in that case, you form groups. You can solve something. Okay, nicely. Okay, and then if you are not sure whether you are doing things properly, you can actually do the assignment and ask us, present us with something. Does that look okay? Yeah. So we hope that by using a study method like this, both of us will be happy. Okay. But this is also what I meant before, to scare you away from this class. So this kind of an assessment policy does not work for everyone. Okay, you need to, you need to have some kind of a time management of yourself, because nobody is going to look after you. Nobody is going to ask you, you should do this assignment now, or what? Okay, you should not skip classes or whatever. So as long as you find it comfortable, yeah, of course, I encourage you to stay here. But on the other hand, we have the same option in a different classroom. We are, so the other class is taught by Professor Mac. Okay, also come from Hong Kong. Yeah, also is in English. So everything also using Kenneth Rawson. And then okay. But then for those who want to stay here, then these are some study tips. Study tips is, first of all, come to every class. Because I didn't mention to you, I won't be teaching. So although I have the lecture notes, it depends on how the general students is understanding. So I may be teaching it quickly or slowly. So I don't have any agenda that this must be taught to you, this must be taught to you. Okay, because discrete math is a policy. It's something that trains your logic. So we have already talked about logic at the beginning. If your logic is good, then you understand everything afterwards. Okay, so instead, I will insert some of the questions. I call it IQ questions. I don't know whether you call it the same way in Taiwan. Okay, in English it's called brain teasers. Some IQ questions here that I find interesting, and then so it wastes some class time. Okay. So come to every class so that you don't miss any one of them. And then the next one is ask questions. Okay, ask questions. You can ask it during the class. Yeah, because your question maybe there are other students sharing the same question with you. So when you can formulate a question, it is good for both. One is you train your mind how to ask a question so that everybody understands what you are saying. Okay. this is difficult. Okay, sometimes you ask a question, but nobody understands what your question is saying. Okay. Now, the second one is you help also your classmates, so they may have the same doubts. Okay. So ask questions in class, after class, send us emails, whatever. Okay. And then do every assignment. Yes. Although it doesn't count. Okay. Form study group, help the others. Yeah, by helping the others is the best. Okay. Because if you can explain things clearly to your friend, this means that you understand the things properly. Okay. So, and study ahead you may, because the notes are already there. And then, most importantly, this is most importantly, I hope you like this course and then have fun. Okay, so.